Hey everybody, today we're going to learn about the sine graph. So we started a little bit of trigonometry, just kind of hitting the highlights since we're right here at the end of the semester. Today we're going to study everything about sine. So if you think back to right triangle trigonometry, you might have heard of SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Today we're going to focus only on the sine graph and different properties that we can do with the graph. And then I'll show you about period and frequency and how we can find the period and frequency for different graphs. So let's get started. All right, so first I'm going to show you what the sine graph looks like on my paper, and then of course I'll type it in Desmos so we can get a better picture of what it looks like. So I have these 5 points over here that I'm going to type into Desmos so that we can see what we get. So let's see if I can pull up both at the same time. Okay. So I'm going to first type in the sine of 0. Make sure when you're in Desmos that if you're doing anything dealing with trigonometry that you're in radians. So where my cursor is at down here at the bottom, you can toggle back and forth between degrees and radians. Make sure that you are in radians. So I'm going to type in the sine of 0, and I got 0, so I'm going to fill that in. Next, I'm going to do the sine of pi halves. And make sure when you type it in that you put some parentheses so that only that number is in parentheses. There we go. I got 1. Next, I'm going to type in pi, just regular pi. I got 0. Then I'm going to do 3 pi halves. 3. And I think this one needs to be in parentheses. 3 pi halves. Okay, I got -1. And then I'm going to type in 2 pi. 2 pi. And I got 0. So what I did, and let me shrink this just a little bit so you can see my numbers here. What I did, I just took these numbers and I plotted them. I typed them in Desmos so we can get the exact values. We can get these by hand, but for the sake of time, we can use Desmos. So when I typed those values in, I got 0, 1, 0, -1, 0. So I've already plotted those. 0, 1, 0, -1, 0. I am going to connect these. And this is what the basic sine graph looks like. And I'll be out your way in just a minute. Okay, so it makes a wave. So this is what the sine graph looks like. It makes a wave. It goes up and down, up and down. And it's going to continue to do this forever and always. So it's what we call oscillates. So oscillates, think of like a wave. It just continues to go up and down, up and down, up and down. It's going to repeat over and over again. So the sine graph and the cosine too, but today we're just looking at sine. The sine graph is going to go up and down and up and down and up and down. So my domain is going to be all real numbers. My domain is from infinity to infinity. But my range, however, if you notice, my peak is +1, that's my maximum, and my minimum is -1. So my range goes from the numbers 1 to -1. So my domain is going to spread left and right forever and always, but my range only goes from 1 to -1. So now that you've seen a rough little sketch or graph of what it looks like, let's definitely take a look in Desmos and see what it looks like. So in Desmos, again, make sure you are in radians. So if you hit the toolbar over here on the left, make sure the radians is highlighted. I'm going to type in the parent graph, which is f of x equals the sine of x. So here is the wave that I drew on my paper. And as you can see, it just continues to go up and down forever and always. You can zoom in, zoom out, but this is my basic sine graph and it oscillates. As you notice, it's never going to get above +1. This is pi halves 1. This point is pi 0. This point is 3 pi halves -1. And it never gets below -1. So of course I can shift it and move it and things like this, but this is my parent graph and this is what it looks like. So now let me pull up what the formula is. Not necessarily a formula, but maybe our generic form. And so we can go through and see what each number in front of the variable tells us. So A sine bx minus c plus d. The number right here is the amplitude. The b is your period. C is the phase shift, and D is what we determines if it moves up or down. So we have the amplitude, the period, which I knew for us, phase shift, and the D on the outside is going to move it up or down. So let's go through our definitions, and then I'm going to use Desmos again to further illustrate to you what these mean for us. So the number in the front is your amplitude. It's the height of your wave. So I've drawn a picture down here. This is my theta axis, which normally is our x-axis. So this is the horizontal axis here. From the peak of your wave to the axis, that is your amplitude. And it doesn't matter if you look at your maximum down to the axis or if you look at your minimum up to the axis. This space here, the height of your wave, that is called the amplitude. The period is how often it repeats itself, and we're going to be doing some examples with that in a little bit. So the period of a wave is the length of one cycle. How long does it take before your wave repeats itself? So if I look at the parent function, this wave, it went up, went through the axis, came back down, and it started over again. So for this particular parent graph, my wave is, my period is 2 pi, because it took 2 pi, that's the amount of time it took before it repeated itself. It started here on the axis, it went up, it went through, and then it went back again. So that period is 2 pi. We can make it change, but my parent graph, the length of time that it takes before the wave repeats itself is 2 pi. Phase shift is a new terminology for us, but that moves it left or right. And the number on the outside moves it up or down. So these hopefully are very similar to what we've done earlier in the semester, with the exception of maybe the amplitude. Maybe that one's a little different. But the other numbers, the number on the outside is called our phase shift now. It's going to move left or right, so it's going to shift the whole graph left or right. And the number on the outside is going to move it up or down. So before we get into some problems, let me pull up Desmos and see. So, okay, that's good. So I'm going to try to get all this in here and then also look at our graph. So we're going to do some sliders on Desmos. This is something you can follow along with as well, so that we can see what each number is going to do. So I'm going to add this A slider. That's going to be sine X. And inside of here, so each time you add a new variable, you can add a slider. Then I'm going to do minus C. I'm going to add a slider here. And then on the outside, we're going to put plus D. So what I've done is this generic form that's over here on my paper on the left side of your screen. I've just typed in A sine BX minus C plus D. And I'm going to go through and press each of these so you can see the effect that it has on my sine graph. So right now, I'm going to press play. So if you notice, this A is your amplitude. This is the height of your wave. So notice my ordered pairs are not necessarily shifting totally up or down. It's still staying in the same central area, but the height of my wave is either getting taller. Notice it's at 9 right now, or it's going to shrink back down to the regular one, which is like 1. So notice how that is going to change. So let me try to get it really close back to where we started from so that we can move on to the next one. So let's make this B1 because that's my basic one. So I'm going to make that B1. Now let's press B and see what happens. This is your period. This is how long before your wave repeats itself. So let's press play here. So this is repeating often, and this is taking a long time. So think of like a slinky sideways, if you remember slinkies from back in the day. So this one here is repeating quickly. My wave is repeating quickly. So if I use my cursor key, I'm going up, down, up real fast. Up, everything's happening fast. As opposed to when I stretch it out, it's taking a longer time to repeat itself. Okay, so again, I'm going to put this one back at 1. All right, let's see what C does. C is going to move your graph left or right. Notice how my graph is shifting left and right. The whole entire graph is not stretching vertically or horizontally. The whole entire graph is moving left or right. And I'll set this back at 1. And finally, let's see what D does. D is going to move it up or down. So notice the whole entire graph is being moved up or down. So this is what the A, the B, the C, and the D, this is the effect that it has on my sine graph. So we'll put this back at 1. All right. So that was just a quick little thing. I think Desmos is a great tool to take a look at the different effects that it has. So the amplitude is the height of your wave, and here's an illustration down here from your peak down to your axis. That's your amplitude. Period, we are about to discuss a little bit more in detail in just a minute. Your phase shift moves left or right, and the D, the number on the outside, moves it up or down. So let's talk about period a little bit more. Period is the length of one cycle, how long it takes the wave to repeat. The parent sine function, as we talked about, has a period of 2 pi. So it'll be 2 pi units before the wave goes up and back down and then back to that same exact spot that it started with. So we can make the period shorter or longer. This is our formula for how we find the period. Is 2 pi over the absolute value of b. So in just a minute, we're going to be going through and doing some problems and finding the period of different sine functions. The opposite of the period, or the inverse of it, is called the frequency. The frequency is the number of cycles it completes in a given interval, and that formula is the reciprocal of this. So it's the absolute value over 2 pi. So make sure that you get both of these. We're going to be working predominantly with the period so we can see how long it takes the wave to repeat itself. All right, so I got some examples. Make sure you have your formula, 2 pi over the absolute value of b. And I'm going to write the formula on this page for us. So this is the formula that we're going to be using, 2 pi over the absolute value of b. So here we go. B is the number that is in front of your x. So let me put that formula back up here just for a moment here. B is the number that's in front of the x. So that's the number that is going to be going in our denominator. So for the first one, always a good idea to write our formula down, which I have. So my formula, 2 pi is going to stay 2 pi. And I'm doing the absolute value of b. B in this problem is the number 2. This is, you can do some mental math with this, but 2 divided by 2 is going to give you 1, or type it in Desmos. So this time my period is pi. So what this means is it's going to repeat every pi units. So within pi, it's going to start on the axis, go up, go through it, go down, and then go back to the axis. So my period is pi. Number 2. This time my b is 0.5. That's the number in front. So my period is 0.5. Again, either mental math or you can type in Desmos, 2 divided by 0.5, 2 divided by half. You should get 4 pi. So this one repeats. This one is slow. So my parent graph repeats every 2 pi. This one repeats every 4 pi. So it's been stretched out a little longer. It takes a long time before it repeats itself. Number 3. 2 pi, my b is 3. I can't simplify 2/3 any more than what it already is, so that's my answer. Number 4, b. B is 1/4. So this is written top, bottom, numerator, denominator, but I also can write this as 1/4 times x. B in this problem is 1/4. Mental math, or type that in Desmos, you get 8 pi. And the last one, 2 pi. Again, b in this case is 1/5, so I can rewrite this as 1/5 x. Mental math, or type in Desmos, and you get 10 pi. So the period of your function is the length of one cycle. So I want to end this video just by going back to Desmos just for a minute. Let me get rid of A, C, and D. Okay. And I'm going to press play for this one. Okay. Let me get rid of all those. Sine B of X. Now let me press play. So you can see what's happening. This is what I mean by the period. So if I highlight, I start here. This is going to go up, down, go back up, and then it repeats. Now, as opposed to if I make it bigger or longer, say I stretch it out a little bit more like this, notice how long it takes for this one to reach the axis again. So notice it goes there, and then it goes back through here. So if I highlight, this is where I'm starting from, this point right here in the red, and then it's going down here. So that is one period. Notice how stretched out horizontally that is, as opposed to something like this one, where it's going to start here and then it reaches back to the point here. So period is the length of one of your, period is the length of a cycle of a wave, excuse me.